So welcome back to 30-Day Excel Analyst, the course where we're trying to transform your analytical toolkit in 30 days. And this week is data analysis week. So remember, we talk about 4 key skill areas in Excel. We've already covered data management, so many interesting topics there, including Power Query. This week is data analysis, and lots of people think Excel is just about data analysis. Well, we know there's 4 different areas of activity of skill in Excel, but data analysis is certainly an important one. In today's session, we're going to look at what's called continuous numerical data and do a quick data analysis. It's something that I see lots of professionals struggle with. So that's the plan for the next 20 minutes or so. If you're watching live, leave me a comment in the chat. Thanks so much for joining us live. If you're watching on replay, leave me a comment below. I'll get back to you there. I'm trying to make sure you can get as much value as you can out of the 30-day Excel Analyst program. So with that said, into today's resources, as always, the resources are available. The link is in the video description below. So day 9, and we're moving on to data analysis this week. And we've got our summary slides. So on 30-Day Excel Analyst, we are big on overviews. The main overview being there's 4 different skill areas in Excel. This is our main overview of data analysis. So there's some things that aren't on here that we will cover this week. So when we're thinking about data analysis, the most obvious option is a pivot table. But we're going to say with today's data, pivot tables just isn't the best way. So it's very important to understand when we're doing data analysis, what kind of data are we dealing with? We can see our definition at the top here. What is data analysis? Data analysis is the process of making sense of a data set by counting, categorizing, or doing whatever you need to do to the data set. But firstly, this idea of making sense, what kind of data have you got? What kind of data have you got? If you've got what's called continuous numerical data, which is what we're looking at today, pivot tables, well, they're not really going to work. Some Excel formulae could be helpful. Here's one of my Excel secret weapons that we're going to deploy today. So the key question is, what kind of data do you have? So how do we, how do we think about data? What are the main concepts here? Well, just 2 simple concepts to begin with, discrete or continuous data. Now, if you're dealing with text data, you need to analyze text, then your data is going to be discrete. If you're analyzing numbers, the data could be discrete or continuous. So what's the difference? Well, discrete means you have one of a limited number of options. So if you were rating a service from 1 to 5, you would have 1, 2, 3, or 5. So although that data is numerical in form, it is discrete data because there's one of a limited number of options. Now, continuous data is a number that falls within a range of numbers, and it could well be a decimal. So unlike discrete data, you're not going to have the same values occurring again and again. You could have a whole data set, as we're going to see today, with no value appearing twice. So this is the idea of continuous numerical data. And it's always fascinated me in my career. People really struggle with this type of analysis. So with that said, I'm trying not to swear because my computer is just not working. Trying to do a very basic thing using Excel shortcuts here. Just trying to switch over to Excel, and we are in Excel today. Now, so make sure you download the download file, and we can see here we've got 2 data sets. So what is this all about? It's the Dogbit download data. Have you heard of the Dogbit app? You won't have heard of it because it's fictional, unless I've subconsciously stolen it from somebody. If I have, I do apologize. But it's the Dogbit download data. So the Dogbit app records how far in meters approximately does your dog walk each day. And we've got Luna the dog here, and we've got Lola the dog. So we've got 2 data sets here. A very typical thing you might want to do, compare 2 data sets. To what extent are these 2 data sets the same? So how would you go about this? Well, firstly, you just go through, get a feel for the data, and just looking at this data, you're thinking, well, yeah, they look about the same. I suppose that they look quite similar. Anyway, we've got 1,000 entries here. Yeah, and understanding how many entries are in the data. You can see that broadly speaking, they look similar, but what we're going to understand in the next 10 minutes or so is they are actually completely different. The nature of the data is completely different. So What do you have to do in Excel to understand that? Build up a picture of the data. And I mean a picture in a literal sense almost, because we're going to do a chart as well. So with that said, let's get to it and let's start with our Excel formulae for data analysis. So the first thing we want to know is how many entries, how big is this data set? We're going to do that with the count A formula. So you can see I've typed in count A, then Control Shift and down, we're going to select that first column. So you could just hit enter now. That formula is going to work absolutely fine, but we're going to put some what's called a partial absolute reference in this formula. So I'm hitting the F4 key, and you can see that dollar sign is moving around. So that's changing between what's called this is a relative reference to a full absolute reference to a partial absolute reference. Now, this is what we're interested in. We're just looking to have a dollar sign between the letter and the number there. What's that going to do? That's going to fix the row. It's not going to fix the column. So we're not going to go too deep into this, but this is what's called a partial absolute reference. In modeling week next week, we'll talk more about these dollar signs, but we can see a single dollar sign in there. That's going to fix the row. It means when we move the column across, we're going to be able to look at the data that we want to look at here. So what we're going to do, we can see we've got 1,000 entries in our data. You could confirm that by going Control Shift down on the Windows PC, and you can see we've got count 100 here. So just validating what's happened. Always try to do things in Excel at least 2 different ways. Then I'm going to go Control R on the Windows PC and Control D. Now that looks a bit strange, doesn't it? We've just got the same formula repeated, but as we'll see, this is a speedier, a faster way of doing it. Now just take the time now to check these references. We've got our partial absolute reference. What we're expecting to happen is for that reference to move across. It has moved across. That's because the formula isn't fixed. There's no dollar sign. That's because the column rather isn't fixed. There's no dollar sign to the left of the letter, but the row is fixed. So as we go down these formulae, we can see the row reference is the same. And the column reference has moved across. So that's the power of partial absolute references. So first question is, what's the size of the data set? We've got 1,000 entries here. What could we do next? Well, what about summing up the entries here, just using the sum formula? That's going to give us a feel, isn't it, for the scale of the data. And yeah, it's a quick way to understand, are these data sets different? And we can see we've got the data summed up there. What's that? 3,395,000, but 3,362,000. So roughly these 2 data sets, they're in what I'd call the same order of magnitude. They have the same number of zeros after them, if you like. Now, to be a teacher's pet, you could go ahead and just validate this, Control Shift and down. I can see at the bottom of Excel sum 3,362,705. So we just validated what we did there. Okay, so count A, sum. What's next? Let's go ahead and find the maximum value in this data set. So max formula, Control R on the Windows PC to take that across. And yeah, this is the first kind of notable difference, isn't it? So the second data set, Lola's data set, has a higher maximum value. So that's intriguing, isn't it? So we're just beginning to build up a picture, and you can see, we're going to see in a second anyway, it's about more than doing just averages. We're going to talk about that more as we go through the session. So the maximum seems different. What about the minimum? So Control R on the Windows PC, and you can see it's also different, isn't it? So significantly less for Lola here and significantly more. Now we've got the min and the max, we can get the range. So we're going to depart from this little formula template, if you like, that we've been using. To get the range, we can subtract from the maximum value the minimum value. That's going to give us the range. And this is our first notable difference here. You can see the range significantly different for Lola's data. Does that mean the averages are going to be different? Interesting. Let's go ahead and have a look. So yeah, a typical thing that somebody might want to do is just get an average of a data set, but it really is a misconception to think that tells the whole story of the data, as we're going to see now. So because these 2 data sets, they have a similar average. We're using the mean average now. We've got mean, median, and mode. We'll talk about the other 2 in a second, but the average formula gives us our mean average. So What's a mean average? All of the entries are being added together and divided by the number of entries. All of the entries added together and divided by the number of entries. That means that any one entry is going to impact on that average figure. Well, you might say, of course it is, Chris. That's the idea of a summary measure like this. That's true, but median is slightly different. That's why I recommend you use both. So mean, control R here, we can see, yeah, the mean average is quite similar. So if you just fired up Excel and did a mean average using the average formula, you'd have a completely inaccurate picture of this data set because, yeah, the means are the same, but that doesn't mean the range of the data is the same. You can see the range of the data here is dramatically different. Okay, let's try median then. So the concept of median, all Excel's doing in the background is lining up all of the values in order and then picking out the middle value. Lining up all of the values in order and then picking out the middle value. So why is it interesting? That's interesting to us because that way of finding an average, it isn't influenced by what you'd call outlier values. So if there's a single very high value, then the mean is going to go up, and it might go up significantly depending on how high that value is. The median won't go up because we're just taking the middle value in the data set. It doesn't matter if there's a value of 1 million at the end of the data set. It's not going to affect the median. Now, this is interesting for us because I can see Luna's data, the mean and the median, not too far away. Yeah, the order of magnitude we're working at, they're pretty much the same. But I can see, yeah, once again, the median here is lower for Lola's data. What does that say to us? Well, the mean is affected by all the values. The mean is higher. That says to me there's a greater range of values, but we already know that. But at the top end, there might be some outlier values at the top end. There's some more bigger values at the top end because those values are affecting the median, the mean rather. Those values don't affect the median. So if there's a big discrepancy between the mean and median, that's telling you about the dispersion of the data. Finally, our third average is mode. Not particularly useful for this data set, but I wanted to throw it in to show you, yeah, there's different averages and they tell us different things here. So what's the mode? The mode is the most commonly occurring value, the most commonly occurring value in a data set. So as I said, maybe not too important for this kind of data set, but we've got a value for Luna here of 3114. So let's go ahead. I'm going to use COUNTIF here. So COUNTIF, incredibly useful formula in data analysis. I want to establish how many times does this mode value, how many times does it appear in the data set. So COUNTIF, we give Excel a range and we say within that range, how many times does a particular value appear? Try and choose the keyboard here to build this formula. I'm going to hit enter and I can see 4. So that value of 3114 occurs 4 times. 4 out of 1,000, not particularly important, I would say, for this kind of data, but often with discrete data, the mode might be important to you. And I've just copied this across here, and I can see 2294 is also appearing 4 times in Lola's data set. So mode is included, maybe not particularly important for this kind of continuous numerical data, but absolutely essential for continuous data is a measure of dispersion, There's 2 key concepts for us to focus on when we're analyzing numerical data: central tendency, so that's our averages, mean, median, and mode, and then dispersion. So to what extent is the data dispersed? Because you could have data that's very tightly packed in would give you the same mean average as data that's very spread out. So we also need to consider dispersion, central tendency, and dispersion, the 2 concepts here. Right, so we can go STDEV here. It's going to give us the standard deviation. Then just from what you know so far, our discussions about the range, about the differences between the mean and the median there, what would you expect the standard deviation for Lola's data to be? So now you're having to interpret a data set. This is what the Excel analyst has to do: tell the story of the data and explain its significance in real world terms. Why does it matter to your manager? Why does it matter to a business person? Why does it matter to the person who's running a charity, who you're doing some pro bono work Excel? This is the work of the Excel analyst. Yeah, it's not just getting the formulae to work, it's interpreting things for people. We're translators. Right, so 507 standard deviation and 1431. So clearly a big difference there. A quick conceptual explanation of a standard deviation. So taking all the values in the data set and it's finding the average distance from the mean average, if that makes sense. So we're saying for Luna's data, on average, the entries are 507 away from the mean. The difference between each entry and the mean on average is 507. And then for Lola's data, the difference between the mean and the values on average is 1431. So clearly, very different data sets. Yeah, very different in nature. But if we just looked at the averages, we wouldn't be able to establish that. Okay. We've got more coming because these summary measures are great, but visuals are so much more impactful as data analysts. And we've absolutely got to understand this continuous numerical data. And this is another thing people really struggle with, how to convey this in a chart to really tell the stories of these data sets. We know these stories are very different, but yeah, people just much prefer looking at a visual rather than looking at tabulated numbers like this. So how to do that? Excel secret weapon time. Yes, the frequency formula. Are you using the frequency formula? I absolutely love it for analyzing continuous numerical data sets. So to apply the frequency formula, we've firstly got to have a sense of the range that we're working in. So I can see from our min and max formulae, the minimum value is 472 and the maximum value is 6295 here. So what we're going to do, the concept of frequency is we're going to create bins. We're going to create bins. We're going to use intervals of 500. You could use whatever intervals you want. So 0 to 500, 500 to 1,000, 1,000 to 1,500. And then Excel is going to take all of these values and just drop them in whichever bin they drop into and then count the number of entries in each bin. So we've got the concept of bins, entries being dropped into those bins and then counted. So a beautiful way to simplify and interpret continuous numerical data. So we've got to first define our bins. And we do that using the concept of an upper limit, Can be confusing when you're using VLOOKUP. When you're using VLOOKUP with approximate match, and we'll be doing that later in the program, you use lower bounds to define your bins. When you're using frequency, you use upper bounds. So this will effectively be any number below 500 is going to fall into this bin. But our concept is bins of 500. So I can just say J4 plus 500 here, and then I want to drag this formula down and I want to encompass all of the data. So I can quickly glance back to our tabulated measures here, and the max is 6295. So Control D on the Windows PC, I need to go above 6295, and there we can see our bins laid out here. But what do these bins actually mean? Just going to put a 0 in here. So this bin is going to be between 0 and 500 here. So I'm just using the ampersand, the and sign to concatenate, to join together a cell entry and a text entry here. So 0 to 500, and for completeness, the boundary is inclusive as well. So a value of 500, I believe, would drop into this bin as well, but you can test that yourself. I don't want to get too lost in the detail. That kind of thing doesn't matter when we're trying to build up an overall picture of the data, which is what we're trying to do. So Control D on the Windows PC. And this is a better way to describe the bins, but the frequency formula won't understand the bins described this way. We have to describe the bins using that single value, which Excel will understand as the upper limit. But these entries were just created serve a dual purpose. The other purpose is, can you guess what it's going to be? The other purpose is going to be as axis labels for our chart. Yes, we're going to create our frequency formula and then create a beautiful chart from that. Control C, Control Alt VV. We're going to convert to values that. We're ready to create our frequency formula. Now, I call it the most difficult Excel formula because there's a particular way we've got to build it. We've got to be very steady and systematic when we build it. It will not work first time. I bet today it doesn't work first time. That's all good. We can always start again. So steady and systematic, step by step. Let's go. Step one. So this whole column, we're going to select. So all of the cells where we want the formula to appear, we're going to begin by selecting all of those cells. So just held down the shift key there and down arrow here on the Windows PC. Then we can type in equals frequency. And as usual, we get our prompt. So Excel is saying data array, data array. So Excel is saying where's the data that you want to analyze. So I've gone to the top of Luna's column here, Control Shift down. Then it's crucial I remember to do what now? At the beginning of the session, we had a quick discussion about partial absolute references. This time we're going for a full absolute reference. So we can see, count them, 1, 2, 3, 4 dollar signs in there. That's a full absolute reference. That's because as this formula comes down, and it's going to come down automatically because we've pre-selected the cells, we still want the formula to refer to the same data set. That's a classic error with frequency and with other data analysis formulae in Excel. Now we can go comma and bins array. Well, we've set up our bins using those single values, understanding that those single values convey an upper bound. Once again, we want to hit the F4 key because we don't want those references moving down with the formula. Okay, so now we're going to close the bracket and then just relax a second. Usually we can just hit enter and kind of rock and roll. We've got to hold down Control Shift and hit enter here. This is something we have to do with the frequency formula. I think it's because it's what's known as an array formula. So I'm holding down Control Shift on the Windows PC, hitting enter, and then suddenly we can see the magic of the frequency formula there. We can see it's entered with these double brackets. I think that's because it's an array formula. I'm not sure of the precise reason, to be honest, but it doesn't really matter to us. So did you manage to get the frequency formula working? Not easy to build, but well worth it. Okay, so let's practice. Excel is a skill. We've got to do that repetition. So let's try to do the same thing for Lola here. So the data array, it's going to be the adjacent column, Control Shift down, F4. I'm looking for 1, 2, 3, 4 dollar signs here, and then comma. Excel now asking for the bins array. So I'm selecting that single value column. I'm not selecting the column that gives us both sides of the bin, if you like. Hit the F4 key again, 1, 2, 3, 4 dollar signs in there. Then I've got to relax. I want to just hit enter, but I've got to hit Control Shift, holding down Control Shift, hitting enter there. And you can see the frequency formula at work. I'm just going to say this is Luna, this is Lola. But even that, we haven't got onto charting the data. But even that tells us quite a lot, doesn't it? Tells us quite a lot about what's going on here. Could we even shift in some nice formatting here? So Control C, Control Alt V and T, obviously for formats here on the Windows PC. That's looking pretty good. Let's hit the F4 key here and Control C and Control Alt VT here. So the power of the frequency formula, creating those bins, then dropping values into those bins. Quick validation check here. So if frequency has worked, then all of the values in the data set should be accounted for. So I'm going to add up all of the values that frequency gets us. So the totals for each bin gives us a total of 1,000 there. And the same for Luna gives us a total of 1,000. Okay, so frequency, very nice, but it would be better to communicate this visually. So we're going to try to create a chart. Now, what I recommend you do when you create a chart is you pre-select some data. So I've just pre-selected the bins, just the single value for the bins there, and Luna's values. Now, this is not what we want to display eventually in the chart, but I suggest you build it up step by step using something simple first. Let's see how we do. So I'm going to go to insert, and then I'm going to go for a bar chart here. And this is what we've got. So it's not exactly what we want, but that's okay. We just took an intermediary step there. So for the category, the axis labels, this is where we want our boundaries that we've prepared earlier. We can hit OK here. And then series 2, is it series 2 that we want to remove? No, it's series 1 that we want to remove. So let's remove. Okay, let's just start again. So let's say series 1. I'm going to select Luna's data here. So Control Shift down, and then series name, select Luna there. Okay, the chart's coming together. And then we're going to add another series here. So this series name is going to be Lola. And then the series values, Control Shift down here. Okay, enter. So I can see two series now being displayed on the chart, and you're just seeing how different these data sets are. And then for the labels, we can select those cells in which we prepared the full title, if you like, and that gives us our chart here. Pretty cool. Pretty cool. So what does that show us? Well, just looking at the data, as we did at the beginning of the session, we were saying, well, it looks quite similar, but you can see actually completely different. So in terms of central tendency, we looked at the mean, and that's quite similar. The dispersion is completely different here. So Luna's data following, that bell curve, what you call normally distributed data, and then Lola's data here, following what you'll call, I believe, a bimodal pattern here. So you've got two peaks, and although it's giving the same mean average, actually completely different and much higher dispersion in Lola's data. We can see that because we've got these big bars out to the side. And then a little bit more, because the mean was higher than the median for Lola, we can see up this end. You can just appreciate the bars are a little bit higher, although I appreciate that's a marginal thing. That's a little bit higher. That's because the mean rather is higher than mode. We do have some high values that's elevating the mean that won't affect the median rather. And excuse me, I think I mixed up median and mode there, but you'll be able to get the sense of what we're talking about here. So that's how to do it, guys. That's how to tell the story of a numerical data set using our basic summary measures, but you've got to get to the chart, guys. You've got to get to the chart. Managers don't look at this stuff. Seriously, busy people do not look at stuff like this. Busy people love stuff like this. We're translators, we're interpreters. We're not sitting in ivory towers doing technical stuff. That is not what the modern Excel analyst does. The modern Excel analyst tells the story, makes sense for people, helps people with their day-to-day work. Now, if you've got any final comments, guys, put those in the chat. Tomorrow, we're going to move on to pivot tables. I'm going to show you my super easy approach for building a dashboard, a basic dashboard using pivot tables, using slices. Later in the week, we're going to talk more about data analysis, formally dashboard building, all kinds of good stuff coming. But just on this topic, my recommended follow-up video here is data analysis 5 steps. So you can see in the video description below. Can't do data analysis in Excel, just do this. So this is a short video, about 10 minutes. It's one of my edited videos. It's not a video like this where I just end up going on for the whole time. It's really concise, and it takes you through any data analysis problem. It takes you through what we were talking about at the beginning, understanding what kind of data have you got, text data, numerical data, is it discrete, is it continuous, understanding those things. That determines your choice of tool, the best tool to use in Excel. I'll take you through the whole methodology here, although it's only a quick methodology, in 5 steps. That's in the video description below. So with that said, guys, let's get into the chat. Let's see who's been with us today. And as I said, any final questions, guys, pop them in the chat. I'll deal with them now. And if you're watching on replay, thanks so much for watching, and leave me a comment below. I will get back to you there. So good morning to the general. How are you doing, Jorgen? Always good to see you. Lee, you're with us. You're going to be with us this week. Lee, thank you for dropping in. Marcus dropping in as well. So Marcus over in Cairns on holiday. Fantastic stuff. Arnie with us too. How are you doing, Arnie? And Lee says, yeah, you missed a few, been away, but playing catch up will be caught up by tomorrow. Fantastic stuff. Lee, okay, Michelle with us. Michelle, long-term fan of the channel. How are you doing, Michelle? Always fantastic to have you tuning in. Okay, that's it for today's sessions, guys. Thanks for watching live if you've been watching, and we will continue tomorrow when we're going to get into pivot tables and my super easy method for developing a lovely visual dashboard based on pivot tables. I'll see you the same time, same place tomorrow for more from 30-Day Excel Analyst. Take care.